and then I forgot to push go again. So, well, hey. No, I want you to tell me for sure. Okay. The microphone, so I checked the microphone, didn't even push play. So, no, outstanding. Yeah, because you can see the blinking light tells you it's going. So thank you. 2 points for Allison. Anybody else? No, don't hesitate to tell me. I want to make sure we're recording. So.
Can we talk about 74?
Yes. Elijah, did I answer your question?
Yeah.
Okay. 74. Let's make a quick list just so I can kind of analyze which things you have questions about. So other questions anyone has that got through the whole homework? Please, Lindsay. Anything else? Please.
Did we do 68?
Which one?
68.
So we got that. We're good.
Oh,
no worries.
sorry, yes.
No worries.
So I had a general question.
Uh-huh.
When we're solving for like a limit when x approaches like a value and not infinity, do you also want us to find like the f of that like value? Does that make sense?
Yes. 2 points for Maddie. Good question. Listen. There was nothing in the homework that explicitly said when you're finding the value of a limit as x approaches some number to find the value of the function or at that same value. I did ask you, it is a good idea to do that, okay, primarily so that you are understanding the entire picture of what's going on. The limit tells you what's happening when x is close to 0. This tells you what's happening when x is exactly 0. And in today's homework, I will explicitly ask you to write this down so you can make comparisons. So that's why.
Sounds great. Thank you.
If you forgot, it's fine.
Okay, thank you.
Because I didn't put it explicit. Weston?
Can you help with 61?
61? Anybody else? Please.
63.
Anyone else? Okay, cool. Here we go.
We do 71 also.
So what we'll do is we'll kind of start working on these, and then once in a while we'll hit something that's pretty similar, so I might skip it, but we'll take a look.
I just have a question. Like 72, you know it's infinity pretty fast, and so it's okay that you don't do all the notation.
Correct.
Okay, awesome. That was nice.
No, perfect, Maya. Hey, something like this, they don't really expect you to write anything. I've never seen it asked except on a multiple choice question. You can just write it down. It's totally fine.
I also noticed, like, as far as like writing your work and stuff, that you like to, every time you do equals, like write a limit and then x to something. Do you have to do that, or can you just like,
outstanding.
write fractions and stuff to make it faster?
Gotcha. 3 points for that. All eyes up here, everybody. When you're solving a limit, you have to keep writing limit. On the written portion of the test, if they ask you to do a problem related to limits and you don't write limit, you will not get any points. Yeah, it's very strict. It's very strict. It's really because part of what they're testing is your ability to communicate mathematically. They give lots of cases where you can just kind of think on your own, scratch work, but where they want to see written work, it has to be correct. Good question. Yeah, they're very strict. Okay, cool. 74 was asked. Let's look here. Okay, 74 is a great example of an AP question. I tried to create a limit problem that is different than anything else in the entire worksheet in a subtle way. So you have to rely on your ability to analyze. Like I try to teach you the method of analysis, and you just have to follow that method, even if the problem looks different. So let's give some extra credit to the whole room. So when you see a limit problem, what's the first thing I taught you should be thinking about? Hands up if you can remember. Everybody know. It's like, what's the first thought that needs to come to your mind when you see a limit problem? First thought, everybody. First thought, Trey?
Would it be whether x is going to infinity or?
Perfect. My first check is x approaching infinity. How many knew that's what I was thinking? 2 points. Since x is not approaching infinity, don't take that approach. What's my second thought always after that? Hands up, come on. I need you to think. You want to think with me. You'll learn far better than if you just listen. So what's my second thought? If x is not approaching infinity. Cambry? How many knew that one? 2 more points. So x is not approaching infinity, and there's nothing to factor. It's just nothing factors. So the third option, which I don't think I emphasize as much as I maybe should have, is you just have to think about what limit means. So limit means when x is close to 0, what will the formula give you as the y coordinate? So I go here and say, if I put in a 0 for this x, e to the 0 is exactly 1. So e to close to 0 is going to be pretty close to 1. So the top is going to be very close to 10. You will need me to do that again. On the bottom, if I put in close to 0, the bottom will be close to 5. So I figured it out. As x gets close to 0, the value of this limit is 2. And then f of 0 would actually be exactly 2. So this function is continuous at 0 because the value of the limit and the value of the function are the same. Question? You need me to talk about it again? Please.
So you don't need to factor the x to the 3 plus 5. I mean, I know it's a crazy number, but...
Gotcha. I had the same reaction you did, Weston. I look at it and think, was there any way to factor that? And I'm thinking, seems kind of crazy. I can't think of a way, so I just abandoned that path and said, hey, maybe it'll work if I just think about what limit means. But in many cases, you can factor, and you need to do that first. So it's
Okay.
a little bit tricky to.
So, like,
Right.
you can't factor that?
You can, not an easy.
So, okay.
There's no easy, quick way to factor that. So.
Yeah.
Outstanding. 2 for Weston. Anybody else? Okay, let's look at 68. Okay, I did this last period, so we have a little bit of a head start here. 68, x is not approaching infinity. Skip that thought. However, the bottom, now this is back to Weston's comment, the bottom is a difference of squares. So that will factor and factor very quickly. So I get to here. Questions. And what I get is these matching factors. Oh, please, Avery.
So I've never heard of the difference of squares. How does 1 minus x squared become 1 minus x squared and 1 plus x? Because then isn't that like taking it away from x squared, 1 away from x squared instead of x squared away from 1?
Oh, let me say it back to you and see if this helps. So they call it a difference of squares because 1 times 1 is 1, and x times x is x squared.
Right.
And you can always factor this difference by simply taking the square root of each term. So the square root of 1 is 1, square root of x squared is x. And then you get a 1 minus and a 1 plus term. You multiply them back together, I'll have you help me. What's 1 times 1? Good. This times this would be these two. And then these two. So with the difference of squares, the 2 middle terms always add to make 0. And so it really does work writing 1 minus x squared as 1 minus x multiplied by 1 plus x is equivalent. Is that your question?
Yeah.
Perfect. Anybody else? Cool. Okay, eyes here. I want the whole class to raise hand and answer the question. The reason we factored was we were hoping to get this. And the key thing about this fraction is if we don't plug in actually let's plug in exactly 1 first. Hands up, what does this become if we plug in exactly 1? Come on, think with me, everybody. If we plug in exactly 1, what does this ratio become? What is it? Undefined. How many knew it? 2 points. So that's why I say f of 1 is undefined, because if you plug in exactly 1, that's what we get. Plug in anything other than 1, this becomes, there have to be 1s in this discussion. Plug in anything other than 1, this becomes 1. And all you're left with is this to be multiplied. So when x gets close to 1, this will get close to 2, hence the limit is 1/2. We need to discuss that further. Solid? 61. x is not approaching infinity, so I look to factor. The top is a difference of squares. As I mentioned to Noah, make sure you use the notation. That is very accurate. If it's a written question, they really won't give you the points. So we go x minus a, x plus a, questions. So it's nearly identical to the last problem. This is equal to 1. Actually, it's equal to undefined if x is exactly negative a. If x is close to negative a, this is 1. You end up with negative a minus a. That's going to be very, very close to negative 2a. Plug in a little more. Very, very close to negative 2a. Hence, the value of the limit is negative 2a. You want to discuss that? Please,
Do you always need to do the approaching from the right and approaching from the left, like a little less and a little more? Okay.
Yeah, 2 points for that. Limit, you can never find, this is called the two-sided limit, or overall limit. You can't find the two-sided limit unless you have found both the left and the right.
Okay.
Now, in a lot of cases, I'll do that kind of quickly by, instead of saying a little less or a little more, I'll just say, hey, if we're close to A, this is exactly 1. And if we're close, sorry, negative, if we're close to negative A, this is close to negative 2A. But I'm thinking both sides, for sure. Good question. Please.
So should we be writing it as equals negative 2a, or should we do the approximate?
Gotcha. So this is kind of Noah's question as well, too, for Danny. Because the value of the limit is always a precise number. It's never an approximation. It's always, we're getting very, very close to this. So to the answer to a limit question, always put equal.
Okay.
This was my scratch work, me kind of thinking, okay, what happens when I plug in the value?
Okay.
When I plug in the value, you don't get 2a. You get close. That's why I did that.
Okay.
They won't look at this, Noah. They'll just realize this is you just doing some scratch work. It's fine, however you want to write it. Here, they'll want to see the right notation. Perfect. Anybody else want to discuss this? Cool. 63. I'm going to let you try 63 on your own. It goes very similar to this. Well, I'll just show you that. Hold on. So we factor. I'd factor out a 10 to start with. Factor a 5 from the denominator. Break everything up here a little bit. Anyone have anything about that that's not feeling comfortable? Please, James.
Isn't the a squared on top a to the 4th?
Oh, thank you. 2 points. My bad. Well done. Anybody else? Solid. So this is equal to 1 unless we plug in exactly a. So once again, plugging in exactly a is going to give us undefined. Back to what I was saying to Rachel. This is 2. This is 1 if we're close to a. Close to a, this will be close to a squared plus a squared. So the value of this limit is 2a squared. wouldn't bother by any of that. Again, as you sit in class, make sure you're really thinking, hey, does this make logical? Oh, I made a mistake. Hadley, it should be.
So, let's see.
Yeah, I see there. Keep talking.
I got 4a squared.
You did.
I'm trying to remember how I did that.
Yeah, you're good. Let me say it back to you.
Just give me a second to like.
You're good. You're good. It's supposed to be 4. I missed
Okay,
that.
so you end up with 2x squared plus 2a squared when you refactor it out after you divide the 10 over 5. And then you've got 2a squared plus 2a squared because x is supposed to a. Yeah.
No, I made a mistake.
Okay.
Well done. 2 points. Yeah, I did this just fine. Where if I plug in 2, so I plug in the a, I get a squared plus a squared, which is 2a squared. I forgot that I had the extra 2.
Yeah.
Well done. You always sense this sense of panic in the room when I make mistakes. Sorry, I don't mean to cause extra anxiety. So. 71, we already did 71, right? So. Yeah. Okay, cool. Let me pass out an handout. Unless you guys have decided to move it, since you didn't move, I assume you tend
Let's see. I spoke to somebody else who was coming from
Yeah, you know, party
I was supposed to respond over the weekend. So there's 8 of us all together. I'm just sitting around looking at there's no drama.
Oh, wait, what?
Smells like some Spanish. No, I would just tell her, I would say everything in Spanish.
Okay, here we go. Look at number 2, please. So, this discussion is just a continuation of the same discussion we've been having. So it should not feel like something new. It's just looking at what we've been discussing in a slightly different way, but very, very similar. It says identify the x-axis location. So again, picture a graph mentally. I'm trying to find where along the x-axis is there a discontinuity in this function. And you've already memorized that there's only 3 types of discontinuities you need to worry about looking for. Removable discontinuity, jump, or vertical asymptote. Okay. Back to Noah, because it was really a good question about notation. This worksheet, don't worry about notation. This is meant to be, I'm trying to guide your thinking a little bit to help you understand how to look for the discontinuities. So where I've given you space, it's just scratch space. Just whatever you want to do is fine. So don't worry about notation on this particular worksheet. Next thing here. So, trying to find out where the discontinuities are located. I look at something like this, and my first thought is factor. So just like limits, if I factor this, good chance I'll be able to identify the discontinuities. So let's do that. So that's f of x. So factored f of x would look like this. So there'd be an x plus 4 squared. That's already factored. The denominator becomes x subtract 7, x plus 4. You pause there. Questions? Please, yes.
So we don't like write out x plus 4 on the top or just square?
Either way, I'm going to actually split them in a second. As I was doing this, my brain was kind of focused on the bottom, but either way is fine. It's totally fine. So 2 for Kes. So now we have x plus 4 divided by x plus 4 multiplied by another x plus 4. That's over 1. Multiplied by 1 over x minus 7. I split out each of the factors because it helps me see better what's happening. Question? Looks good. Okay. So I have a few memorized facts that help me now. One is that if I don't have a piecewise function, I don't have a jump. So for our class, I've never seen a function that had a jump that wasn't piecewise, ever. So for our level of mathematics, if it's not piecewise, it's not going to have a jump. So memorize that. Okay, next thing. When I look at this, I notice that as I've written this out as factors, it makes analyzing the function pretty easy. If x is equal to exactly 7, I don't care what value this is. In fact, I know this will be 1. This is equal to 1. If x is equal to 7, this is 11, although I don't really care that much about that. What's important is this is 0. So if you multiply everything back together again, you'd have 1 times 11 times 1 is 11. 1 times 1 times 0 would be 0. Your voices.
Where did you get 11?
0.
Why is that?
Oh, why 11? I chose to plug in x equals 7. So f of 7. So I chose 7 because I noticed that 7 minus 7 would be 0. So putting in a 7 here gives me 1. Putting a 7 here gives me 11, and the 0 there. Is that your question?
You're just choosing for it to get the denominator to be 0?
Right. No, perfect. 2 points for Brennan. So choosing an x of 7 confirms what I was thinking, which is I end up with number over 0. That's a vertical asymptote. So the vertical asymptote's occurring at x equals 7. That should be familiar from last year, Elijah.
So the vertical asymptote whenever the bottom number is 0.
Right, and the top isn't.
Okay.
Yeah, crucial that the top not be 0. So number divided by 0, vertical asymptote. Weston, please.
I thought if the top number was 0 and the bottom number was 0, that it would still be. Why would that be undefined? Or
Yeah, here's the mix-up. Good question. If the bottom's 0 and the top's a number, the value of the function is still undefined.
yeah.
If the top is 0 and the bottom is also 0, the value of the function is undefined.
Still defined, yeah.
Okay, but the vertical asymptote only when number on top, 0 on bottom.
Okay.
Good question. 2 points.
Wait, so it can be undefined and a vertical asymptote?
So wherever you have a vertical asymptote, the value of the function will be undefined at the vertical asymptote, for sure. You know it's a vertical asymptote because you end up with a 0 on the bottom and a number on the top.
Okay.
2 points. Maybe else. Go ahead, Dan.
So if you plugged in a 4, then you'd have a 0 on the top, it would just be undefined. So would that be the removable? Or?
The negative 4.
Yeah, the negative 4, yeah.
Okay, eyes up here. 2 points for Dan. If you plug in x equal negative 4, this is part of what I was saying to Weston as well. So if we put in a negative 4, f of negative 4 is undefined. But the undefined occurs because of a 0 in the top and the bottom. This is typically a removable discontinuity, although I'm going to show you something to verify that. So this is typically removable discontinuity. This is vertical asymptote.
So it's just a 0 on the bottom and any other number on the top. It's the vertical asymptote.
Perfect. Okay. Perfect. What he said. Now, any number on top, 0 on the bottom, that's where the vertical asymptote occurs. So when x is equal to 7, that's what we get. Number on top, 0 on bottom. When x is equal to -4, we get 0 on top, 0 on bottom. That is not a vertical asymptote. Questions? Cool. So I suspect there's a removable at -4. Let's come down here. They ask us to find the limits as x gets close to -4. So here's our formula. Trying to figure out what happens when x is close to -4. We have already figured out when x is exactly -4, the value of the function is undefined. Close to -4, things change a bit. I want everyone to raise your hand on this. What will this be when x is close to -4? Raise your hand, please. Come on. Hands up. What's this going to be when x is close to -4? Close to -4. Let's go. Chase?
1.
How many knew it? 2 points. So close to -4, this is 1. Close to -4 here, hands up, come on, stay with me. What's this going to be? Close to -4. Think with me, don't just watch. When x is close to -4, what's this? Close to -4. Not exactly -4, but close. What's it going to be, Mikkel?
Undefined. I mean, 0.
Close to 0.
Yeah.
No worries. So it won't be exactly 0 because we didn't plug in exactly -4, but definitely close to 0. How many knew it? Show me your hands. Come on. 2 points. So we've got 1 multiplied by close to 0 over 1. What does this become? Hands up. Come on. Close to -4. When x is close to -4, what's this? Close to -4, what's that going to be? Let's go to Tessa.
1 over -11.
So this will be close to -11. So now you've got 1, how many knew it? 2 points. You got 1 times close to 0 times close to 1 over negative, hey, that's 0 on the top, that's going to be close to 0. So this limit value is 0. Question? Correct me.
I thought there was a 1 on the top. Is there?
You're good. So this is 1.
Okay.
This would be, so we got basically 1 over 1 times close to 0 over 1 times 1 over close to 11. So when you multiply the fractions, it's this times this times this. That would give me a top that is close to 0 and a bottom that is close to 11. So tiny, tiny value divided by number is going to get really close to 0.
Okay.
No, good question. What else? 2 for Dan. Keep going. You comfortable here? Okay, remember back to the quiz, I gave you some notes and said, hey, you need to have this memorized. If the value of a limit, the two-sided limit does not match the value of the function, that's what this is. Two-sided limit is not matching the value of the function, that's a removable discontinuity. So I know for certain now that this is definitely a removable discontinuity at x equal -4. Question? Please, Weston.
Okay. How did you get for the one that's x plus 4 over x plus 4? How did you get 1 over 1 rather than 0 over 0?
Oh, gotcha. So the key difference is keeping track of whether I'm plugging in exactly -4 or plugging in close. So if I plug in exactly -4, for sure 0 over 0. For sure undefined. That's the result when we're finding f of -4. Totally with me?
Yeah.
Awesome. Plugging close to -4, this won't be 0.
Yeah.
To be close,
Yeah.
fair. The key thing is, whatever this is, this will be exactly the same.
Oh, okay. See.
Hence 1.
Yeah.
Perfect. No, perfect question. 2 points. Anyone else? Awesome. Keep going here. We need to figure out what's happening close to 7. So exactly at 7, we already figured out the bottom becomes 0, top is a number, so that's undefined. So precisely at x equals 7, undefined.
What was it? Any number divided by 0 is 0? Or?
The other way around. Easy to get it mixed up.
Okay.
Yeah, it's super easy to get that backwards. So number divided by 0, undefined. 0 divided by number, 0. Perfect. And there's a couple of examples of that right here, Danny. When we plug in exactly 7, this is 1, 11, 0. So number over 0, undefined. When we plugged in exactly, let's see, when we plugged in close to -4, we ended up the other way around, hence 0. Good question. Anybody else? Keep going. So let's see. We want to plug in close to 7. I want you to think with me. So eyes on the board. Raise your hand, please, if you know what this is when we plug in close to 7. Don't overthink it. Plug in close to 7. What's this, Boston? 1. How many knew it? 2 points. Close to 7 here. Hands up. What do you get? Close to 7. Show me your hand. Close to 7. What does this become? Let's go, Ellie.
11.
How many knew it? 2 points. Close to 7 here. Hands up. What does this become? The part I'm circling. Close to 7. What do you get? That's right. Close to 0. Won't be exactly, but close. How many knew it? 2 points. So I've got 1 multiplied by close to 11, close to 0. So I'm back to this kind of a thing, except here's the difference. The bottom is never actually 0. It's just close. So it's back to the rule I was talking to Elijah about. Top being 11, bottom being very, 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 very small, that whole thing is growing forever. So the value of the limit, you can say it's infinity if you want, or negative infinity, it kind of depends. A simpler answer is just to say it's unbounded. Then you don't have to worry about the plus or minus, because it grows forever. This is a vertical asymptote. It would look like this on a graph. You'd have at negative, no, was it -7 or positive? Positive 7. So at x equal positive 7, the function has no value. So there's nothing at x equal 7. But on the two sides of x equals 7, the function has a vertical asymptote. So the y value on one side of 7 is becoming increasingly negative, so it's unbounded in the negative direction. On the other side, the y value is unbounded in the positive direction. That's a vertical asymptote. Questions here? Next thing, go to number 4. Okay, so back here I said that on number 2, we didn't have to worry about a jump because this was not piecewise. This is piecewise, there could be a jump, but we don't have to worry about a vertical asymptote because none of these formulas have a denominator different than 1. So there's no way for the denominator to become 0, hence you cannot have a vertical asymptote. Just put a none right there. Okay, next thing to memorize. With piecewise functions, most of the time, in fact, I've never seen one different ever on the AP test. They haven't gone to a more complex kind of problem. Everything interesting is always happening near these values. So I'm going to suspect that the discontinuities, if there are any, they're going to be near 4. So So let's go looking near 4. So I find limits. We use the limit to identify the discontinuity. So I find the limit as x approaches 4 from the left. So just raise your hand if you know what should be written here. So we practiced this a couple of homeworks ago. What should be written here? If you have a piecewise function, find the limit as x approaches 4 from the left. Just study it out. Raise your hand when you have it. What do I write here? If you're just guessing, please raise your hand. It's much better to participate than just watch me. So you can figure out whether you're following me or not. So what belongs here? Most everybody. Still some thinking. Let's go Anna Kate.
6.
So Anna Kate said left, so she said a little less than 4 means the top formula is applicable because x is less than 4. Close to 4 squared would be close to 16. Minus 10 would be very, very close to 6. Hands up if you knew that. 2 points.
Yeah, I have a question.
Yeah, please.
Is this, like, would you recommend just writing equals, or is this one times when you do it?
Gotcha. If I'm doing a limit, it's going to equal. If I'm thinking of the value of a function, then sometimes I would use approximate. Like if I were doing, so yeah, that's good enough. 2 points for Ben. Anybody else? Awesome, cool. Let's see. So that's the left hand. Let's do the right hand limit. So the limit as x approaches 4 from the right. Cool. So show me your hands. What belongs here? And wrong answer is good as right, so give it a shot, everybody. Let's go, Maddie.
10.
Raise your hand if you would have put 10. 2 points. So greater than 4 means I have to use the formula here. So I plug in close to 4. 3 times 4 is close to 12. 12 minus 2 is close to 10. Questions? Please.
So the only reason why you're choosing to find the limits that it goes to 4 is because it's on that side of the piecewise function?
Because of right here. Yeah.
Okay.
Absolutely. Never seen a problem in the AP test where they start asking questions about a piecewise that they were really very interested in the other x coordinate. So I started focusing here. Perfect. There's a second reason. The other reason is the only other way I've seen something interesting happen is if these can become rational functions, fractions, and they can. So I don't really care. So good question. 2 points. If the left and right limits don't match, raise your hand if you remember what kind of discontinuity that is. Hands up. If the left and right limits are different, who can remember the name of the discontinuity that results when the left and right limits are different? Forgetting it's okay, but who can remember? What's the word that describes the type of discontinuity, Sarah?
Jump.
Jump. Left and right are different, that's a jump discontinuity. So we have a jump at 4. So memorize that. How many knew that it was a jump? Hands up. 2 points. Okay, removable occurs if the overall limit is different than the value of the function. So if the left and right limits are different, we can now write down the overall limit, or the two-sided limit. Show me your hands if you know what belongs here. Hands up. What do I write here? Everybody. Two-sided limit. Just reviewing back from homework 1. What goes here? Some people still not quite remembering. Let's go, Drew. No worries.
6.
What you're remembering is this. Stay with me, Drew, for 1 second. So if I
got confused.
you're okay, no worries. Don't even worry at all. So if I go f of 4, like I plug in exactly 4, I'd look here, and that would be exactly 6. Perfect. 2 points for Drew. What goes here? Hands up. Show me. What goes here? Tristan? Does not exist, but same idea. So the limit doesn't exist if the left and right still match. Like that. Okay. For our removable discontinuity, memorize the overall limit. Okay. First of all, if these two are different, that's a jump, so it's not going to be removable. So there isn't a removable. If these two are the same, that would make this the same, but these being different, that's a removable discontinuity. Okay, let's look over here. Oh, we can finish this now. If you scroll down, it kind of guides you as to what type of things you should be thinking of. So the limit from the left was 6, and from the right is 10. Overall limit does not exist. F of 4 is 6. That's why we have a jump.
But you know it's not removable because it's a jump.
Yes.
Okay, it can't be the same.
I don't know that it can't, but I can't think of a way that it can be the same. So, 2 for Brennan. Okay, come over on this side. So I want to go looking near 3. So let's go find some limits. So the limit, this will, I think, point out the contrast I was talking about a minute ago, Brennan, between a jump versus removable. So when x is close to 3, hands up, what goes here? Katie?
9.
So Cade looks at the top, because x is less than 3. Close to 3 squared to be close to 9. 9 minus 2, so that'd be close to 7. How many knew it was 7? 2 points. Questions? Let's find the other one. Show me your hands. What goes here? Everybody. Let's go, Rachel.
7.
So Rachel comes up here. She says a little more than 3 is the bottom formula, so definitely close to 7. How many knew it? 2 points. Cool. We want to talk about that. Okay, left and right matching can't be a jump. So, and that also means that the overall is also going to be 7. But raise your hand, please, if you can tell me what is the value of the function at 7. So remember, limit refers to, we got 3 points. Limit is the 2 points left and right of the center. F of 7 is right in the center. Question, Heather? Oh, sorry. 3, my bad. Thank you. Too many 7s. So 3 right in the center. 2 points for Heather. Hands up. What goes here? No, always correct me. I just make a mistake. What goes here? Isaac.
2.
Show me your hands if you got 2. Perfect. So this is a removable discontinuity because the overall limit is different than the value of the function. So it's exactly what Brennan said. What I'm checking is, first let's see if the left and right match. If they don't match, jump. If they do match, check for removable. Say it louder.
So this one is removable?
This one is removable at x equal 3. So there is no jump. No vertical asymptote. Question? Please.
So is it, oh, never mind, it's right there.
No worries.
It's removable at 3?
Mm-hmm. Okay, hands up. Who knows what happens if this is 7? Like if all 3 of these are the same. Like this is this, well, if everything's the same, so the limit left and right is the same as the value of the function. Who knows what we call that? So if these are all the same, what do we call that? Rebecca?
Continuous.
Then it's continuous. How many knew it? 2 points. versus discontinuous. So that's what you're checking for. Please.
How does he know if there wasn't a vertical asymptote again?
Oh, the vertical asymptote can only occur if we end up with a denominator of 0. And no denominators here. I mean, these, you can think of these formulas as all divided by 1. So there's no way for the denominator to be, there's no value of x, which can cause the denominator to be 0. Good question. 2 points. Anybody else? Next thing, so scroll down. It'll ask you those same limit questions. You can just fill it out. So. This is kind of a, well, it's a very guided worksheet. So it's not really an AP problem, but it's meant to help you remember what's meant by jump, what's meant by removable, what's meant by vertical asymptote. So. Cool. All right, next thing. Let's go all the way to the back. So look at number, let's do 14 is good. Okay, so problems 1 through 12, you're identifying where are the discontinuities, like where are they located. Those really aren't classic AP problems. They're more kind of some guided practice to just get you used to the idea what's meant by removable, jump versus vertical asymptote. The last 8 problems are much more similar to actual AP problems that they've given in the past. They give a function like 14, and you're supposed to figure out what number belongs in place of A, and what number do I put in place of B so that the function has no discontinuities. You want to eliminate the possibility of any discontinuities. So as I start studying the problem, my brain immediately registers that there's one type of discontinuity I don't need to worry about. Hands up, who knows? Come on, show me. What's the one type I can just cross off my mental list, Allison? How many knew it? Vertical asymptote. Perfect, 2 points. It's what we were saying to Danny a minute ago. No denominator other than 1, so there's no value of x which can cause the denominator to be 0, no vertical asymptote. It's piecewise, so based on my experience with the AP test, I'm only worried about x values of 2 and 4. They just have never given problems where anything else interesting happens. So I'm going to go looking near 2 and 4. So I'll do limits. So do the limit from the left as x gets close to 2. And as usual, raise your hand and tell me what should I write. So as x gets close to 2 from the left. Oh, and if your answer has an A in the answer, it's totally fine. So if you can't get a complete value, it's like A times something, A plus something, that's fine. Just get used to dealing with the unknown constant. So what do I write here? For hands, think with me. What do I write here? Let's go Noah. So Noah comes up. Says x is less than 2, so he's looking here. So close to 2 plus 1 would be close to 3. 3 squared is close to 9, so 9 times 8. How many knew it? 2 points. You wouldn't want to talk. You don't want me to talk. Cool. Let's find the other limit. Or we could go in order, I guess. We could go find what f of 2 is. So what do I write here in purple? What's f of 2? Hands. What's f of 2? Just waiting for everyone to think. So when you plug in exactly 2, what will the output y coordinate be? Maya?
9a.
So let's see. When x is exactly 2, same formula to get an exact result of 9a. How many knew it? 2 points. Anyone want to talk? Superb. Let's do the next limit. So now a little more than 2. Show me your hands. So when x is a little more than 2, what's the value of the y coordinate? So we catch up in the thinking. X is a little more than 2. News about raising your hand up and down all period. It's hard to go to sleep. So helps a little bit. Let's go, Lindsay.
18.
So Lindsay got 18. Please show me your hands if you also got 18. 2 points. Cool. All right, here we go. No vertical asymptote. We want it to be continuous. We don't really care whether it's a jump or removal. We just want to get rid of it. So the way to make that happen is if the left limit, the right limit, and the value in the center, it's your 3 fingers again, if they're all the same, no discontinuities. It's continuous at 2. So I can make this function continuous at 2 by choosing a to have a specific value. Show me with your secret ballot what a must have to make this continuous at x equal 2. Give yourself 2 points. Cool. So we found the value of a. We don't want to talk about that. Please.
So you just want all 3 of those to multiply, or you want all of them to be the same?
Right. So for a function to be continuous at x equal 2, the limit on the left, the limit on the right, the value of the function in the middle must all be the same.
Okay.
And if I choose to replace a with 2, that'll work. This limit would have come out to be 18, 18, 18. So we're perfect. Good point. 2 points for Daniel. Okay, we still have not found the value of b. Do that. Go. I'll just walk the room. Ask me if you have a question. So find the value of b. Just stop if you want to talk one-on-one. Show me your hands if you got this. Do something wrong. something else. Talk to me, sir.
So when I plugged in the 4 for the second and third, I got 30.
Right here.
Yeah. You did just X.
Oh, I know what I did wrong. How many can see my mistake? That's awesome. Keep your hands up. You saw my mistake. Who sees it? What is it, Trey?
You just added 4 instead of doing, you did x plus 14, so 4 plus 14.
Oh, smart.
Like,
No, that's very smart. That's not what I actually did. That's very good. How many thought that's what I did? That's cool. No, really, it's very good. 2 points. I actually did something else, but you can see another error that I could. That makes perfect sense. I just kind of didn't notice the squared. It's awesome. Allison. Yeah, I forgot that I've got to go to 4. Like I just left the others. So how many saw that one? 2 points. Anybody else see anything else? Cool. So that's the mistake. So Hadley, what was this supposed to be? What was this supposed to be? My bad. This one here, sorry.
34.
There we go, thank you. So this is 34.
Just 30.
Oh, this is 30.
Oh,
Yes.
sorry, it's 30. Yeah.
My bad. Don't worry.
B is 30.
You're good. Gotcha, I see what you mean. So this is 30. This is also 30. Too big of an eraser. That's right. This is 34. Thank goodness that wrong is as good as right, as long as we figure it out. Say that all the time. Cool, hands up, who has it? Nice of them. Give yourself 5 points, good work. For the extra anxiety caused by my mistake of the board. Questions? Perfect. Okay, eyes on me. Just wait for everybody to look up. Brandon, look up for a second. Okay, I hope you're seeing a couple of distinct patterns. Really, mathematically, all we're doing on all 3 homeworks so far is, if you throw out the whole idea of x approaching infinity, that's kind of a separate way of analyzing things. Otherwise, we're just factoring and then checking limits and checking the value of the function and then making comparisons. That's all we're doing. So as long as you can remember to do that, you can usually figure out what they want you to do as it relates to discontinuities. It's really that simple. Just factoring and limits. So, okay, go to number, next page. Let's go to 20. Okay, the goal is the same. Make sure that this function is continuous. So we want to make sure this function is continuous. Right here, I'm a little concerned because it is rational. So I'm going to factor to see if I can understand better what the function's behavior is. So we'll factor that first before we find the limits. So let's see, f of x. I don't want to really write that. It's not f that I'm factoring. I'm just factoring that little formula. So I'm just going to do some scratch work here. So I won't use an equal sign. So this becomes 2 multiplied by, let's see, x and x. The 21 is 7 and 3 multiplied. They both subtract. If I factor the denominator, I factor out of 4. That gives me x minus 7. So now I can see what I have. I've got 2 over 4, x minus 3 over 1, and x minus 7 divided by x minus 7. Question? Okay, so once I factored, I noticed that anything interesting is going to be happening near x equals 7. This was a big hint about that. This is confirmation that that's where they want me looking. If I'm not near x equals 7, nothing else is happening that's going to cause a discontinuity. Question. So I do the limit thing. So We find the limit from the left. As x gets close to 7. So when x is close to 7, please raise your hand if you can tell me what's the value of the limit. So if x is a little less than 7, what's the value of the limit? Show me your hand. Just letting everyone think. So when x is, so I look up here and say, if x is exactly 7, no, it's not that. X is a little less than 7, so I'm here. So I'm using this, but I don't want to use that. That's hard to understand. This is easy to understand. So when x is close to 7, say it out loud. What's this? What is it? Come on, say it. This is 1. So that's 1. When x is close to 7, this is 1. This would be close to 4. 1/2 times 4, so the overall limit is 2. Show me your hands if you got this. Show me. 2 points. Okay. You don't want to talk. Weston, talk to me. Something's bothering you.
I got 6 over 4, but
You're okay. Just work it through. Is it okay that this is 1?
oh, I just didn't multiply right.
No worries. You good?
Yeah, I'm good.
Perfect. 2 points.
So
This
would
one
that
here.
be 0 over 0? Or?
The difference, Trey, is this.
Oh, 'cause
We're not-
it's almost 7?
Almost 7.
Okay, okay.
No worries. You good?
Yeah.
So you're good now? Perfect. 2 points. Anybody else? Solid. Let's go find the value at 7. So show me your hands. What do I write here in red? Cambry. So Cambry looks here correctly, notices that you don't use this formula when x is exactly 7. You use this value. So f of 7 is precisely it. Show me your hands. How many got it? 2 points. Let's find the limit from the right. Hands up. What's the limit from the right? No?
2.
So same logic as before. We're using this formula. Limit from the right is 2. How many got it correct? 2 points. To make the function continuous, all 3 must match, so A must be 2. And we fixed a removable discontinuity is what we fixed here. Question. Outstanding. Homework is the pink. So good work. Well done.